Good morning, friends. Our next experiment is Kirchhoff laws. So we have two types of Kirchhoff laws. One is Kirchhoff voltage law, another one is Kirchhoff current law. So by using this circuit, kit, by using this kit, we are doing both KVL and KCL. Kirchhoff voltage law and Kirchhoff current law. So in our circuit we have different resistances here, 100 ohms and 120 ohms. E means that one also indicated with ohms. 100 ohms, 120 ohms, 220 ohms, 330 ohms and 390 ohms and 470 ohms, 1K and 2K and 5K. But we are using only these three resistances only, 100 ohms and 120 ohms and 220 ohms. It's mean I am going to explain theoretical values by using these three resistances only. For these three resistances I am going to explain KVL and KCL also. So for KVL also I am going to take these three resistances, and KCL also I am going to take these three resistances only. So here especially we are going to discuss about ammeters also. Ammeters are there here, but in KVL we are going to take a drop voltage only, but no need of any current values. Because of that, these ammeter value we are going to bypass it by using one patch cord from here to here. Then only we can take it R1 resistance, R2 resistance and R3 resistances. So we can connect these resistances here. Okay, these resistances here, and then wherever dotted lines are there, that particular condition there is no any connection between these two circuits. That's why we can take one patch cord here to connect this circuit and this circuit. So here we are taking only three resistances and 3 voltmeters. For that I have taken 3 voltmeters here for KVL only. And here you remember, no need of these values. We are taking only 3 resistances. No, that's why from here to here I am going to bypass it. Here to here and here to here. Okay, and by using these particular variac, whatever it may be, the voltage regulator, by using this voltage regulator I am going to take a 15 volts, because theoretical calculation I have done for 15 volts, 15 volts. So by using this regulator I am going to take 15 volts, but maximum range of this regulator 0 to 20 volts only. Okay, then I am going to explain theoretical calculations here. You remember KVL experiment. Okay, so first Kirchhoff voltage law statement. It states that the algebraic sum of all the branch voltages around any closed loop is equal to 0 at all instants of time, or otherwise source voltage equal to sum of drop voltage in the loop. So దీన్ని ఎక్స్ప్లెయిన్ చేస్తాను చూడండి. ఇక్కడ మనం సోర్స్ వోల్టేజ్ 0 to 30 volts వరకు వేరీ చేసుకోవచ్చు, బట్ ఇన్ అవర్ ప్యానల్ వీ హ్యావ్ ఓన్లీ 0 to 20 range only. So 0 to 20 volts in the sense, here I am going to calculate only for 15 volts. It's mean I am taking a source voltage here 15 volts. The arrow mark indicated it's a variable voltage. Arrow mark indicates it's a variable voltage from 0 to 30, but here I am going to take only 15 volts source voltage. So for that 15 source voltage drop across certain voltage or across R1, and some voltage drop across R2 resistance, and some voltage drop across this R3 resistance. So what is the V1 drop voltage and V2 drop voltage and V3 drop voltage? Sum of these 3 voltage drops are equal to source voltage. Sum of these 3 voltages equal to source voltage. It means 15 volts equal to drop voltage of these three some voltage. That is the statement only. Source voltage equal to sum of drop voltage, Okay. So already I said here I am going to take source voltage only for 15 volts. For that only I am going to do calculation part. Here calculation for Vs is equal to 15 volts. So Vs is equal to 15 volts. So here V1, what is a V1? Basically here you remember in this entire loop we can consider current is I. Okay. So formula according to Ohm's law, formula is V is equal to I into R. So across V1, across resistance 1, what is the voltage drop? That voltage drop V1 equal to in that particular loop current I and resistance R1. So already I said we will be going to take R1 resistance 100 ohms. So that's why here I into R1 resistance 100 ohms I have replaced here, and then next V2. So V2 in the sense across resistance R2 what is the voltage drop? So that voltage drop equal to loop current I into resistance R2, that is equal to I into R2 resistance. Already I said I am going to take 120 ohms. Then V3 equal to resistance across resistance 3, what is the current? So this loop current and as well as across this resistance value. So it's mean I into loop current is I and across resistance. So we are going to take that R3 resistance is 220 ohms. Okay. Then here we don't know current I value. So that's why first we are going to calculate I value. So I value we are going to calculate Vs is equal to V1 plus V2 plus V3. So we are going to substitute source voltage. Already we have taken 15 volts. That voltage I am going to replace here 15 volts and I into 100 ohms, and it's mean this V1, V2, V3 values I am going to substitute here. I into 100 plus I into 120 plus I into 220. Okay. Then we can take it 15 equal to, here all the cases I is common. So then remaining 100 and 120 and 220 ohms I am going to club it. Then we can get it 440 value. Then 440 into this I value. Then 15 volts. Then I equal to 15 by this 440. Then we can get it 0.03 amperes. Okay. So it's mean we can get it current value in the sense that current value we can substitute in each and every voltage value. It's mean V1 and V2 and V3. Then I am going to replace V1 equal to I into 100 ohms, that is equal to current 0.03 into 100 ohms, that is equal to 3.40 volts. Then V2 equal to I into 120, that is equal to 0.03 into 120, that is equal to 4.09 volts. Then V3 equal to I into 220, that is equal to 0.03 into 220 equal to 7.50 volts. Then eventually we can prove here source voltage Vs equal to V1 plus V2 plus V3. Source voltage already we know that one is a 15 volts, though that 15 volts I replace here, and then V1 already we got 3.40 and V2 we got it 4.09 and V3 we got it 7.50. Then we can sum these three values, we can get it 14.99. It's mean approximately equal to 15 volts. It's mean because of that we can prove KVL theoretically 15 volts source voltage equal to sum of all the drop voltage around the loop. This is the theoretical calculations. Then we are going to see the practical value. So I am going to connect this circuit. Good morning friends. Today our topic is experiment on KVL. KVL means Kirchhoff voltage law. This is the theoretical calculation of Kirchhoff voltage law. First Kirchhoff voltage law statement I have written, and then circuit diagram, and then calculation part. Okay, you remember whatever it may be the circuit diagram, or otherwise whatever it may be the kit you have in your lab. So according to that you have to calculate whatever the calculations we have, but the procedure is same. So here in our kit we are taking 100 ohms and 120 ohms, 220 ohms, but in your kit it's a different resistance values, in the sense you have to take those resistance values. Okay. This is the complete entire calculation part. See my dear friends, here I am going to remove all the voltmeters because the connections are more and more. Because of that I am going to take one multimeter. I am going to check each and every voltage, R1 across what is the voltage, R2 across what is the voltage, and R3 across what is the voltage. I am going to check by using only this multimeter. Okay. So first I am going to turn on this circuit, and what actually we have taken power supply 15 volts. So here ammeter I have bypass, and here also second ammeter I have bypass, third ammeter also I have bypass. I have taken R1 resistance 100 ohms, and R2 resistance I am going to take here 120, and R3 resistance I am taking here 220 ohms. Then you remember I am going to turn on the power supply here. Okay. Then I am going to check power supply voltage here. You remember I am going to set in multimeter what is the power supply voltage. 15 volts I am going to take it. Okay, 15 volts. 15 volts here power supply. Then I am going to remove this value. First I am going to take across R1 resistance. What is that voltage? 3.42 we got across R1 resistance. In theoretical also we got same value 3.40. Theoretically 3.40 we got, but it practically we got 3.46. Okay. Then I am going to take across R2. What actually the R2 across R2 voltage 4.08. Theoretically we got 4.09. Theoretically we got 4.09. Then I am going to take across R3 across I am going to take reading value. So that one is 7.65. Here I got minus, that minus because of interchanging of polarity only we got minus 7.65. So practically we got 7.64 across R3 resistance. So theoretically we got 7.50. Okay. So theoretically whatever the values we have calculated, that values we executed practically by using Kirchhoff voltage law kit. Okay.